Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of second derivative test. So as per the problem, determine the critical points for the function and use the second derivative test to decide if the point is a local maximum, local minimum or neither. So we are given this function s equals t plus t exponent -1. So we have to find the critical points for the function. So we have to find the points where the derivative is equal to 0 because at those points the tangent is horizontal. And then we have to find whether those points represent local maximum, local minimum or neither. So let's start by finding the derivative of this given function. So we get s prime equals, so the derivative of t is just 1 and then plus. Now for t exponent -1, we should use power rule to find the derivative. So as per the power rule, we should move the exponent -1 to the front. So -1 times t, and now we have to subtract 1 from -1 in the exponent. Now we can simplify this expression. Now this second term will become a negative term and the exponent is -2. Now we can move the t term to the denominator to make the exponent positive. Now we can set this derivative equal to 0. So we can sub in 0 on the left side. And now we have to solve for t. So we can move -1 over t squared to the left side of the equation, and that will make this term positive. Now we can cross multiply the denominator. So 1 times t squared is equal to t squared. And now we can apply square root to both sides to convert t squared to just t. So on the right side, the square root and the square cancel each other out. So we get t equals plus minus 1. So there are two critical numbers for this function. T equals -1 and t equals 1, at which the derivative is equal to 0. Now we have to sub in these three values one by one in this given function to find the corresponding function value. So let's start with t equals -1. So we get s equals -1 plus -1 exponent -1. Now for the second term, we can make the exponent positive by moving it to the denominator. Now we can evaluate the fraction. The -1 exponent 1 is equal to just -1 and 1 over -1 is equal to -1. So we get s equals -2. So the critical point is -1, -2. Now we can sub in t as 1 in the given function. So we get s equals 1 plus 1 exponent -1. Now we can move 1 to the denominator to make the exponent positive. So 1 exponent 1 is just 1 and 1 over 1 is equal to 1. and 1 plus 1 will be equal to 2. So the second critical point is 1 comma 2. So these are the two critical points at which the derivative is equal to 0. Now we have to find whether these points represent local maximum, local minimum, and or neither. And for that we'll use the second derivative test. So we'll have to find the derivative of the s prime. So we can use this equation. So s prime equals 1 minus t exponent negative 2. So now we have to find the derivative of s prime. So that will be s double prime equals. Now the derivative of 1 will be 0 because 1 is a constant, and then minus. Now we have to use the power rule. So we have to move the exponent to the front, so negative 2, and then subtract 1 from the exponent. Now we can simplify this expression. So double prime of s, the 0 goes away, and minus negative 2 becomes positive 2. And we can move t to the denominator to make its exponent positive. So this is the expression for double prime of s, or second derivative of s. Now we have to check whether the second derivative for the t values is negative or positive. So the rule is that if the second derivative is less than 0, that means the critical point represents a local maximum. And if the second derivative is greater than 0, that means the critical point represents a local minimum. So let's start with t equals negative 1. So we can sub in t equals negative 1 in the second derivative. Now in the denominator, negative 1 cube is equal to negative 1. Therefore, we'll get a negative value for the second derivative. So that means there is a local maximum at critical point negative 1, negative 2, because we use the t value negative 1 for this test. Now we can do the test at the other t value. So t equals 1. So we'll sub in t equals 1 in the second derivative. And we know 1 cube is equal to 1. So the second derivative will be, so we'll get a positive value. So that means the second derivative is greater than 0. So that means there is a local minimum at the critical point 1 comma 2. So this should be the final answer for the second part of this problem. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.